Welcome back to the introduction to the clinical histology lab. In our last video, we went through the 6 general work areas of a clinical histology lab, and we talked a little bit about each of them. In this lesson, we will use 360-degree media and talk a little more in depth about what happens in some of the work areas. Just like the first lesson, this lesson will have a few questions at the end, but keep in mind, what is important is that you understand the connections between each work area. Before we get started, let's do a quick review of the 6 work areas. Number 1 is accessioning. This is where various types of tissue samples are received and given a unique tracking number. Number 2 is grossing. This is where the specimen gets documented, sectioned, and prepared for processing. Number 3 is processing. Here's where the tissue is placed in chemicals that remove water from the tissue and replaces it with paraffin. Number 4 is embedding. Hot tissue is solidified by chilling it in a mold. Number 5 is cutting. Tissue is thinly cut and placed on glass slides. And number 6 is staining. Glass slides containing tissue is stained and cover slipped, after which is then given to the pathologist for his review. Now that we're done with the short review, let's go a little deeper into what happens in the histology lab. Number 1 is, of course, accessioning. And even though this is a very important step, for now, you should just know that accessioning generates a number specific to that patient's sample. Now let's take a look at the second area called grossing. What you see here is the grossing tech grabbing a specimen which he's about to do the grossing process on. He is now laying out the green cassettes, which contain the unique number that was generated in the accession area when the specimen was initially received in the histology department. He is now documenting and verifying what has been received by the use of a voice recorder. Once the verification process has been completed, the grossing tech will start dissecting the specimen. To get an idea of what is being documented, let's take a moment to listen to this dictation.
Is a 595 gram, irregularly shaped, intact and complete singleton placenta, which measures 22.0 by 18.5 centimeters after trimming period. The umbilical cord is white-yellow, trivascular, measures 41.5 centimeters in length and ranges from 1.2 centimeters near the placental end to 1.6 centimeters near the fetal end in diameter period. Approximately 2 coils per 10 centimeters are present on the cord. The cord has an eccentric insertion, which measures 2.5 cm from the nearest placentatus margin period. The fetal membranes are thick, slimy, opaque, dusky, and yellow, with the point of rupture measuring 2.0 cm from the nearest placentatus margin and 13.0 centimeters from the umbilical insertion site period. The membranes have a marginal insertion period. The fetal surface is smooth, slimy, dusky, and yellow-blue-pink with intact vessels demonstrating a majesterization pattern and ranging from less than 0.1 cm to 1.0 cm in diameter period. A slight amount of sloughed-off white amnionodosum is identified along the fetal surface period. The maternal surface is intact, mesenchymal, spongy, and red with wall-formed cotyledons and a slight amount of adherent blood clot present period. The placenta's thickness ranges from.
Now that the grossing has been completed, the grossing tech takes the representative sections and places them into the green cassettes for further examination. These cassettes will go into the next area in histology, which is processing. The details of what occurs in the tissue processor is beyond the scope of this lesson, but it is good to know that in the tissue processor, water is removed and is replaced by hot paraffin. It is also good to know what it looks like when the tissue processor is loaded. Notice in this video a cage full of tissue cassettes are loaded into the processor. Once tissue processing is completed, the tissue is removed from the tissue processor and transferred to the embedder. Here are the embedders you saw in your first lesson. Now let's take a look at what embedding looks like as it occurs. View the video over the embedder. As you can see from the video, a specimen is placed into the metal mold filled with hot paraffin and then oriented so it can properly be cut, and is placed on a cold plate until it is completely solidified. Here's a demonstration of what it looks like when a mold has been completely chilled and therefore solidified completely. Once the excess wax is removed, it is ready for the next area, called cutting. What you see here is a block being cut using a microtome. Thin sections are made and floated on a water bath. Each section is about 3 to 5 micrometers thick. When a good section is identified on the water bath, it is picked up by using a glass slide, which is then air dried and ready for the next step, which is staining. This is what it looks like when the slide and corresponding block has been cut. Notice the mirror image on the block and slide. Before we can stain tissue that are on slides, we need to heat fix the tissue to the slide. We do this by placing them in an oven. Once they're removed from the oven, they go to the multi-stainer. Look for the word multi-stainer to identify its location. As I stated in our previous lesson, staining can be done by hand, but automation is always preferred as results are more consistent from patient to patient. Once the multi-stainer is done, the slides will get cover slipped. The process of cover slipping is taking another piece of glass and placing it on top of the tissue that's on the slide. This preserves the stained tissue and allows the pathologist to see the tissue clearly under the microscope. Now the pathologist is able to view the slides. During the review, the pathologist will take the information that was generated during grossing and the information on the slide and write a report based on his findings. Those findings are placed in the medical system's records for the patient's follow-up medical care. As stated in our previous lesson, once the pathologist is done with the slides, the blocks and slides will be stored in an archive for at least 10 years. This ends another lesson for the introduction of clinical histology.